Alright, so now that we got some knowledge in our back pocket about OOP, we can start talking about an important concept in OOP, which is inheritance. We're going to start building relationships. Inheritance, just like the name implies, allows us to inherit from a class, a base class, a parent class. This is the class that subclasses will retrieve properties from. So just like in real life, how you have a parent and you have siblings, and sometimes that sibling may get that compliment like, man, you look just like your parent, because there are certain properties that your sibling or even you have that look just like your parent. You're not the same person, but you have properties that you can grab from your parents. Like I said, your nose, your eyes, the way you speak. So the same thing implies in OOP. You may have a parent class, a base class that is similar to the subclasses. Like they're the template, and you have subclasses that branch off from that. So that's the importance of inheritance. When a project gets big and you know that there's going to be classes that are very similar, you might want to have a template that those subclasses can retrieve from. So in our project, we've been using the house pretty much for every example in relation to a class and objects. So what is a house in the grand scheme of things? A house is a building, and there are various different types of buildings, and it's just not a house. It can be an apartment, a skyscraper. And what makes these things different is many things. Like a house can be only one resident, where an apartment can be a list of residents or a list of tenants, and a skyscraper can include a list of corporations. They're still considered tenants, but now you're talking about floors and floors and floors of different types of tenants and buildings and the shape, but they're still a building at the end of the day. Let's look into that. So before I used to write all these classes underneath main, let's be proper. Let me make a new class, and we're gonna call this building, and this is where we're gonna make our parent class. Now this is just a regular class, and by default in Kotlin it's final, which means that it doesn't allow for subclasses to inherit from this. Now to make this inheritable, to make this a parent class, we can put a keyword right in front of this class keyword, and this keyword is going to be open. Now we're open for business. Now other classes can inherit from this class because it's open to do so. Alright, so now that we have a open building class, let's start defining some properties that we would want our class or subclasses to retrieve when we build that relationship with the parent class. So we have building as a template, but what does every building have or should have? So if I go into this class, I can start thinking of that. So what does every building have? It should have at least one room. So we can have a property called rooms, and I'm gonna make that a val, and I'm gonna make that an int, and then I'll have a default value of 0, and then I'm gonna have another property called bathrooms because I don't want them making you guys use the restroom outside. So I'll make that a double because, like I discussed before, a bathroom in a house standpoint can be considered half, or can be considered 0.5 if it just has a toilet. But if it has a shower and a toilet, then it's considered a full bathroom. Maybe in a building that it may just be the toilet considered as one bathrooms, but I want to give the user the chance or the opportunity, if they want to consider half a bathroom, they can do that. So I'll make that a double, and I'll have that holding 0.0. Then I will have color, and I'll make that a var because we don't want to restrict the user to just one value for color. It could change. We can get a painter and they can change the color to another type. So we'll make that a string, and we'll have that empty. And we can even have methods. But besides that, a building should have an owner, so they handle the responsibilities of the actual building. So let me just create a property at the top called var, because the owner could change with any real estate property. The owner could change if the owner chooses to sell it or if it forecloses. So we'll have that as owner of var, and we'll make that a string, and it's going to be empty for now. And then we can have a method that prints out the owner. Just a nice little welcome, like hello, I am the owner. So we'll have a function owner prompt, just so that people can know who's the owner. Open that up. No parameters, because we're just going to retrieve the owner value. And we're going to just do a println. Open that up. Hello. We're just going to do something basic. The owner is. And then we're going to have some string templating. And we'll just put owner. Oop. Wrong one. It should be $. And boom. Now it's grabbing the owner from the properties and it's going to print it out if it does have an owner. So you probably think we're done, but that is not the case. See, just like how the class needs an open keyword so that a subclass can retrieve the properties, we still have to make, because by default, you know, a class is final in Kotlin, but the properties also need the open keyword for the subclasses to override the value if need be. So just gotta put open in front of the properties that you want subclasses to be able to change. So we can just do that and change that. So I want all of these to be open so that if my subclasses want to change it or retrieve it, it is possible. So now everything's open. Everything's open for business. Now let's create a subclass that will be inheriting or building that relationship with the parent class of building. So I know a house is a building, and we've been using it in the previous examples, but we're going to create that class, a specific class just for house. Alright, now to inherit or to make that relationship with the building parent class or base class, all you got to do is put a colon right after the name of the class and put the name of the parent class, which in this case is building. And yes, there isn't a constructor in the building, but we still got to define, you know, a primary constructor. So we can just put an empty constructor because we don't have any parameters that we're accepting at this time. But it is possible, and we're gonna look at that later. But now we have the opportunity to start overriding properties. So to start getting value, so if you want to use a primary constructor from house to start defining some of the values that we took from the building template or the building base class, parent class, we could. So now all we got to do is use the keyword override. All right. And now we just need to use the properties that we define in the building, and we can override those values with whatever value that the user passes into the house constructor. So let's do that. So remember, override, and we have 4 properties. So we're gonna have to create an override for each of these properties if need be. All right, so let's start with owner and file owner, and we're gonna get that string, and boom, the first mistake already, but it's an intentional mistake. As you guys can see, there's a little swiggly that says var property cannot override a var property. So we're able to see that there's a connection. And the issue is that in building, we define the property as a var, right? But in this case, we can't just switch from a var to a val. That's going to cause a problem. So we got to change this from a val to a var. But the weird thing, or not the weird thing, it makes sense. But if this was a val, we're able to make this a var, because the only difference between a var and a val is the fact that a val is not mutable, which means we can't change the value, right? But it's not an issue if initially, you know, this is a, you know, we're not able to change the value, and now we want it to be able to change the value. But before, if it was, we were able to change the value, and now we wanted to not be able to change the value, that's going to cause a problem. So the original class or the parent class could have a val, and then we can override it as a var. That's possible, because now all we want to do is, you know, apply that setter, and that wouldn't be an issue. So just think about that. But now we have to override the other values. So override, and there was rooms, and that was a val, so we can do that, and rooms, and that is going to be an int. And just so that it's cleaner, let's put it each on one line. Oops. And okay. Override. And then we'll make that a val for bathrooms. And then we do one more final override for var, and this is going to be color string. Alright, so now we override all the values that the user passes in, and this is taking reference to the building parent class, and as you guys can see, they're all grown up now, meaning that we overrided the values based on what the user passes in the house class, and now we have access to it. Beautiful. But look, we also define a method in the building parent class, so we can also override that as well because it's open. So if you guys can see, it gives me the option to override the owner prompt, which I want to write it out by hand because it's better to do that so you guys can learn it. Oh, it already we already built it. IntelliJ's too smart. But look, we could define our own prompt here. We just do println, and we can do welcome from, and then put the name of the owner that we passed in through the constructor, if I can spell welcome properly. And now, if I go into the main, I can literally just make an instance of house, pass in the owner, which I'm going to put as Geo. It's going to be a nice little 5 bath or 5 room, 5 or 6.5 bathroom. It's going to be a nice little, I'll make it green or emerald, like some Wizard of Oz type thing. But if I run this after I do the house dot owner prompt, you guys will see the prompt I just created by overriding welcome from Geo. So if I go into building, originally you see the owner is owner, but since I overrided the property and defined my own print statement inside, it pretty much erased everything from here and just defined what I put, which is awesome. But what if we're okay with the original value? So if we're okay with the original prompt, we could just get the instance of the original base class version of it by using the keyword super and then using a dot owner prompt. So now we have the original return value of the method, of the original method. So now we should expect it to return the owner is Geo. So if I go back to the main and I run that, boom, the owner is Geo. And that's just the magic of building the relationship with parent and subclasses using inheritance. Now if we want to use a template, we could. We have a template and now we can inherit as many times as we want within other classes. And now we can even use the original properties or the original method value, or we can create our own by overriding it. We overrided the properties ourselves, and we overrided the method that we created. So either or, we can choose. So that's the cool thing about inheritance. Alright, so just as promised, I created a constructor for the building parent class, and I have the user passing in the market price, and every building has a market price, whether it's low or whether it's high, it still has a price for someone to buy and live in or use. So in this case, I have a market price being taken in from the constructor, and I have a init that's printing out the current value when the person passes in the market price. And then I have the regular properties and method that was originally a part of the building class. So now that you guys seen this, I also created the apartments class. All right, and this is going to be overriding all the properties that we originally had in the building class, but also taking 2 additional properties that is specific to the apartment. So we have a price that is double, and we're not overriding it because it's only specific to the apartment class. And we have a tenants map. This is going to be holding an int to specify whether a person lives, what room the person lives in. You know, because in an apartment, everybody has a room number that specifies, you know, the current location that the tenant is living in. So it can be room 101 for the first floor or 205 for the second floor, things like that. And then we're passing in the price that is being passed in through the apartment constructor. Because we're inheriting from the building, we still have to pass in the value that the building is expecting. So like I said, we have a primary constructor that is expecting a market price. So the price that we're expecting from the apartment, we can pass that to the building class primary constructor. And then once the building class gets that, it will print this right away with the price that was passed in through the primary constructor. Then the tenants, I created a init that will initialize this tenant's property that I created specifically for the apartment class, and it will equal the tenants that the user passed in. And then from there, I created a print tenant that's specific to only the apartment class, and this will print out a tenant based on the ID. So I have a tutorial that I went over maps and how to create a map and arrays and stuff like that. But to get the instance of a specific tenant, I'm passing the ID, which is going to be the room number. I could have used room number, but in this case I'm using ID. And if it's not equal to null, that means someone's living there. So I just print out the current tenant. And because you don't want to just print out all your tenants, like you should only, you know, print out a specific tenant if the person knows the room number. And if that doesn't exist, then that means there's no current tenant living there. So I feel like this is a kind of realistic scenario for apartment, and you can add way more stuff. That'll be a little project for you guys, but this is my apartment class, and this is what it can do. And I'm gonna have the code on my website, which is techwithgeo.com, and I'll leave the link in the description. But now if I go to the main, I'll create an instance of apartments. The owner is going to be GeoCorp. The apartment's going to have 30 rooms, 35.5 bathrooms. You know, there's one bathroom in the office that, you know, doesn't have a shower. So, and then the color is going to be yellow for the apartment complex. The current price for the apartment is $200,000, and we're going to create one map. Like I said, I went over how to, you know, maps and, you know, arrays and the basics of Kotlin in another video. I have a whole playlist actually, if you guys want to look into that. But I'm creating a map with just one tenant. You know, this is a fresh apartment, and this tenant has a room number of 1, and his name is Luke Skywalker. And then after that, I am printing out a tenant. So I'm passing in the ID. And if a person lives there, then it'll print out, you know, who lives there. So in this case, it'll probably be Luke Skywalker because we only have one tenant. So if I run this, boom, the current market price is 200,000.5, which, you know, we specified here, and that's being printed out from the building class from the init, the current market price. As we pass in the market price from within the apartment class, the price that we passed in is being passed in through the primary constructor of building class, which we're inheriting from. And the second print statement is coming from the print tenant, which is current tenant is Luke Skywalker. So if we go back to apartments, it is doing this logic, and it's seeing that there is a value within the map, and it's printing out the current tenant living under that ID or that room number. Now if I go back to main and I put 2, and then I run this, the market price is still going to be 200,000 because that's what we're passing in, but it's saying that there is no current tenant living there, because I mean, if you check the map that we're passing in, I mean, there is no 2. So if we try to see if someone's living at 2, then there's nobody living at 2. So this is how we can use, you know, inheritance. It's pretty awesome. We can have this template, but additionally we can have our own properties that's specific to the class that we made, such as, you know, tenants and price. And even price can be added to the building because, like I said, price is every building has a price, so whether someone is choosing to sell it or not. So You guys can, look at this on my website, or you guys can, write it out and rewatch this to see, how you can add your own properties and logic to make this more robust. So hope you guys enjoy the video.